Welcome to this talk on domestic air tightness testing. I'm Harvey Sandhu and I'm part of Ashby Energy Assessors. We are based in Leicestershire, Melton Mowbray, and we provide expert consultancy on aspects relating to building regulations, energy performance, thermal modelling, building testing, and energy and environmental assessments for both domestic and commercial sectors. So today's CPD will focus on domestic air tightness testing. However, we do offer many other CPDs as a company. So if there's anything else you'd like to know, please leave a comment in the box below or contact us through our website directly. And we can hopefully aim to get something set up in terms of a YouTube video on a topic you're suggesting, or even offering CPD through a Zoom meeting on a topic you're suggesting. So without further ado, let's get into the main body of the presentation. The first thing we're going to cover is Building Regulations Part L. So air tightness testing was introduced in 2006 and further revised in 2010. ATMA currently holds a standard, and their test standard TSL1 is a document all testers follow. Everyone under Ashby Energy is registered under ATMA. However, some individuals in the UK will be registered under IATS, with some individuals operating independently. However, their certificate will need to be confirmed by building control for it to be eligible. The air test score, or air permeability, is given in these units here. We won't go into too much detail with that, but what you need to know is that it ranges from 0, meaning 0 air leakage, to 10. And the greater the number, the worse the air test score. And in fact, anything above 10 will not comply with building regulations. And this is because this is deemed as too much heat loss due to too much air leakage. Finally, an air test score is included in every SAP assessment and is used to determine the final EPC rating. And this takes us on to the next slide, where we'll be discussing the importance of air tightness testing. So having air tests done is a legal requirement for qualifying for building regulations. Without an air test, a dwelling will fail on compliance. Now, the most important aspect of an air test is carbon emissions. So an air test essentially is the act of minimizing the risk of heat loss and energy inefficiency caused by air leakage. This will reduce the cost to heat the property and therefore reduce the amount of carbon emissions for that dwelling. Another important reason for getting air tests done is realizing the contribution to the Part F ventilation strategy. So if you're getting System 3 or System 4 ventilation installed, then you need a low air test to reap the benefits of that system. So this is where both of them come in contribution. And finally, thermal comfort. So when you get an air test done, the air testing engineer can measure the flow of uncontrollable air in the building fabric. This can detect droughts in the dwelling and possibly point out cold spots or otherwise areas of future mold growth. So the next topic we'll be discussing is compliance and EPC ratings. So for every SAP calculation, an air test must be included, and this can largely affect the final compliance document and EPC rating. So we've got two examples here, one with no air test and one with an air test of 5. And what we want to achieve here is determine why an air test is important and why it matters environmentally in terms of SAP and EPC ratings. So these two tables here are taken from the Design SAP software. This is a software that we use to model energy efficiency in dwellings. And what we can see here is the EPC rating, the final compliance, and how far we are from achieving building regulations. So with no air test, we get 82B on the EPC, but we are failing on compliance. And we can see how much we're failing on compliance by these numbers here. So we're quite far off in that sense. That needs to be above 0 to be in the pass. However, on the other side, we got an air test score of 5. We've achieved the 84B this time. We've passed on compliance, and we can see that we're passing by quite a large margin there, or a fair margin there. So from those two examples, we can see how beneficial an air test can be for the EPC rating and how it determines a pass and fail for the final compliance. So the next thing we're going to be looking into is the method of testing. So we've got 100% testing and sample testing. So 100% testing is when all plots on the site are tested, and sample testing is when a handful of plots are selected, they're tested, and an average is calculated from those two and are used for the remaining plots on site. There's a few additional information regarding sample testing, but we'll get into that into a later slide. But for now, we've got the two methods, and the first one is 100%, And the advantage of this method is that it's easy to manage. The design air test score can be more flexible and can ensure more plots pass first time. However, the disadvantage is that it can be more expensive and more time consuming because you're testing every single plot on site. On the other hand, we have the sample testing. So, like I said, this is when a few plots are tested and the scores achieved are used across multiple plots of the same house type. Now, I've put same house type in bold there because we're going to go into further detail in the next slide. But essentially, the benefits of this is that it's cheaper and less time consuming. However, a disadvantage is that the plots that aren't tested will incur 2-point penalty on the SAP, and this can ultimately result in failure of compliance or possibly worsen an EPC rating. So just to go into a bit more detail for sample testing, as it's a bit more complicated. For dwellings to proceed with sample testing, they need to abide by these following rules. So the dwellings need to be of the same generic form, so same house type, for example detached, semi-detached and terrace. Then you have the same number of stories. Then you have the same design air permeability score, same adjacency to unheated spaces, same construction details, same number of openings, for example roof lights or windows by plus or minus 1. The envelope area must not differ by 10%, and at least 3 or 50% of that house type needs to be tested. So if you have 2 of the house type, then 1 need to be tested. If you have 4, then 2 need to be tested. If you have 10, then at least 3 need to be tested. Now, just to go back to the previous slide when I mentioned the 2-point penalty. So if you had, say, 4 plots and you tested 2 of them through sample testing and the average was 5 for them 2, then for the remaining 2, the air test score for that SAP, for those 2 SAPs will be 7 because they incur a 2-point penalty. So yeah, I just want to go into further more detail for that at least. But otherwise, those are the rules for sample testing. If you abide by all these, then you can proceed with sample testing for that site. So just to summarize on everything we've discussed, it's a legal requirement to get an air test done for building regulation purposes. Ultimately, the aim for air leakage testing is to reduce the cost of the heating for that property, which therefore reduces the carbon emissions. And the testing method can be completed in 2 ways, and those are 100% testing or sample testing. So that's it for air tightness testing. If you have any questions, please leave in the comments below or contact us directly through our website. Thank you for watching.